Hello students, welcome back for another class. Our today's topic is non-saturated non-saturated precision rectifiers. Non-saturated precision rectifiers. Now you may be thinking, what is saturated and non-saturated? A topic just before this we discussed was precision half wave rectifier, right? Precision half wave rectifier. So all those were saturated. Now this is called as non-saturated just because of one difference in the circuit. Okay. So let us see what it is. Okay. So let me draw the circuit diagram. This is your V naught. Okay. This is what you have already seen so far. This is your input resistance. Let this be V in. This is your R1. Alright. Let this be R2. This is what you have already seen, right? So let me draw waveform. Later I will modify this circuit to make it non-saturated. This is saturated precision rectifier now. This is saturated precision rectifier. Your waveforms, let me draw. If this is your input, let this be your input waveform. Alright. Yes. How will be output? Your output should be, yes, for positive input. Let us start with this. When you apply a positive input here, that is this portion, this positive half cycle, this positive is given to inverting terminal. So positive will become negative till it reaches output voltage, right? At this point, let me call this point as, okay, let me write it down because I require that space. So V naught dash, let me call this point as V naught dash. What is V naught dash? The output just coming out of your op amp. The actual output is here, okay, after the diode. So this, when you apply positive half cycle here, you will get a negative voltage here, right? So this negative voltage will not forward bias your diode, hence diode will act as a open switch for negative voltage, hence you will not get any output. Okay. This is your V naught, this is your V naught. You will not get any output. You will not get any output. Alright. Next. Next, when you apply negative half cycle of input, your output is going to be, yes, tell me, positive, isn't it? For negative input, output is going to be positive because you have applied to inverting terminal. So this positive voltage at the anode side of diode will forward bias your diode, and diode will act as a closed switch. Diode will act as a closed switch, right? Hence diode will conduct and current will flow, and you will get this negative half cycle passing like this. Understood? So negative half cycle will be obtained. Negative half cycle will be obtained. Now, now this is positive, right? Sorry, I have drawn it down. So this positive voltage will conduct your diode, so you will get a inverted positive half cycle like this. You will get an inverted positive half cycle like this. When you apply this negative input, you will get this positive output. Understood? Once again, when you apply positive input here, this portion, this goes negative and diode will start behaving as an open switch, and once again you will not get any output for this duration. Understood? So you will be getting only negative half cycles getting inverted into positive half cycles only for this duration. Understood? Hence the positive input voltages are clipped here. Can you see? So this will be your output. This is, so far this is saturated precision rectifier. Now what makes it non-saturated, I will tell you. It becomes non-saturated when I connect one. Okay, before connecting, say I am going to connect one diode here. So before showing you how will I connect diode, let me tell you what is happening with V0 dash. What is happening with V0 dash? Let me start with positive input. When we apply positive input here, this will give you a negative output, right? Negative output will not conduct your diode, you know that. Here we have a diode. When this positive input is applied, negative output will come. This negative output will not drive your diode, right? Diode will work as a open switch. Alright, you will not get any output. What happens to V0 dash? What is the voltage here? The voltage here is negative. This negative voltage will drive your output to go in negative saturation minus V0 sat. This will cause your output of your op amp. Which output? This output, not V0. I am discussing about V0 dash. This output at this node, the output goes into negative saturation like this from 0. This is our 0 line. So instead of being at 0 line, your output V0 dash goes into negative saturation level. Here it goes till minus V0 sat, right? Like for example, if VCC is 12, then minus V0 sat will be minus 11 volt, right? So V0 dash will have a voltage minus 11 volt. This is unnecessary action which is happening here. Again, when the polarity of the input changes, again your output has to change from minus V0 sat. First it has to complete this, cross 0, then go into positive. Unnecessary time waste, right? Now we can avoid this. And we can make our V0 dash to remain at 0 line. We can make it to remain at 0 line. For this what we do is, this is your one resist diode. We connect one diode here like this. Okay, so this is your D1, this is your D2. This is your complete circuit. Now it becomes non-saturated precision rectifier. Now you may be thinking, just by connecting one diode, how can we avoid the V0 dash going into saturation voltage? How can we avoid V0 dash voltage going into negative saturation level? This is how, because let us analyze with this. When we apply positive input, positive half cycle input, this will give you a negative voltage here. Alright, negative voltage. Sorry, I made a mistake. This should be, because it should conduct for negative voltage, right? Yeah. When we apply positive voltage, this will give you a negative voltage, right? This will give us negative voltage. This negative voltage will open this diode D2, right? It will not conduct. What about D1? For this negative voltage, diode D2 will act as a closed switch, right? Diode D1 will act as a closed switch for negative voltage, right? Hence, this will form a path for your output voltage. Now a current will flow such a way that, now this branch is completely absent. It becomes like this. Are you understanding? It becomes like this now. Here we have diode. Now this is something like, what voltage we have here? Output voltage, right? A negative voltage. We have a negative voltage. What voltage we have here? We have a positive voltage. So this negative voltage will come here and it will cancel this positive voltage, and you will get a, when you cancel this negative with positive, what is the remaining? You will have 0. You will have a 0 volt. That 0 volt is available here. That 0 volt is available here, 0 volts. Hence V naught dash is avoided and stopped from going into saturation level, and it is limited to 0 volts only. It is not allowed, V naught dash is not allowed to go into saturation voltage. It will remain 0 volts only. Okay. There is another way to show you how you get 0 volts here. That is like in some textbooks I have seen, this is here at this point what is the voltage? The voltage is 0, right? The voltage is 0 here. So with the from virtual ground concept, if this is 0, here also you have 0 volts, right? So when you connect this point like this voltage, if it is 0, this voltage also becomes 0. That is also another concept, but I want you to follow the first concept which I said. Okay, it is this: when diode D1 starts conducting, this negative voltage comes here and it cancels out positive voltage and it will give you 0 volts. Okay, this is how you can maintain V naught dash at 0 line, Okay, so this is what makes it non-saturated precision rectifier. All right, yeah. The design concepts, let me tell you. How will you find R1? R1 equal to input voltage by input current, right? And how about R2? Output voltage by input current. I1, I2 both are same. Then R3 can be taken as R1 parallel with R2. Okay. In some textbooks this R3 is also excluded. Okay. This is how you will be finding out these three values. Hope it's clear. Thank you.